We want to learn about variety of inequalities. The first problem is solving the compound inequalities. We have 3x plus 5 is less than or equal to 5, and 2x plus 3 is greater than or equal to 5. To solve this type of compound inequality, we have to solve two inequalities and then combine it. Let's work out 3x plus 5 is less than or equal to 5. To do that, we subtract 5 on both sides. Then we have 3x is less than or equal to 0. Then we divide by 3 on both sides. So x is less than or equal to 0. Let's work out 2x plus 3 is greater than or equal to minus 5. We subtract 3 on both sides. Then we have 2x is greater than or equal to negative 8. Let's divide by 2 on both sides. That's a positive number, so it doesn't change the inequality direction. And the left side becomes x by canceling out 2 on the numerator and denominator. And then on the right side, we have minus 4. When we denote those results on the number line, we have to notice that both have equality sign. Therefore, at the boundary, in the first case at 0, we have to use disk mark notation. And x is less than or equal to 0, so we made the arrow to the left side. On the right side, we have x is greater than or equal to negative 4. It includes negative 4, so we denote with the disk notation. And then we wrote right arrow because x is greater than or equal to. In this compound inequality, two inequalities are connected with and. That means the solution must satisfy both inequality. Therefore, we have to choose the overlapping part. So minus 5, minus 4 to 0. If we have to denote it with other notation, then we have to use bracket notation, open bracket, minus 4, comma, minus 1, close bracket. In the next problem, we have to solve the compound inequality. Two inequalities are 2w plus 3 is greater than or equal to 7. This time it's or 3w plus 2 is less than or equal to 17. We subtract 3 on both sides, then 2w is greater than or equal to 4. And then we divide by 2 on both sides. Then we have w on the left side, and on the right side we have 2. So the solution is w is greater than or equal to 2. This equality sign tells us that we have to use disk notation here, and w is greater than or equal to 2, so we use the right arrow notation. 3w plus 2 is less than or equal to 17. Then we subtract 2 on both sides. Then we have 3w less than or equal to 15. And then we divide by 3 on both sides. Again, we don't switch in the inequality direction because 3 is a positive number. So w is less than or equal to 5. It contains equality sign, so 5 is included. So again, we use this notation. This time, w is less than or equal to, so we use a left arrow notation. The fundamental differences between the previous problem and this problem is two inequalities are connected with or. That means the solution set will satisfy either the first inequality or second inequality. So instead of thinking about the common part of two solutions, we have to combine two solutions. So when we combine those, we realize that it generates the whole real number line. If we want to express that with interval notation, then open parenthesis, minus infinity, comma, infinity, close parenthesis. In the next example, we have to graph the solution to the inequality on the number line. We have absolute value of y greater than or equal to 5. Absolute value is the distance from 0. This means distance between 0 and the points are farther than 5. So that means on the right side of 0, it will start from 5 and we have to draw the right arrow because just any number on the right side will have distance greater than 5. With the similar reasoning, we have to draw the left arrow starting from -5. So we have right arrow and left arrow on the number line. If we want to express that with the inequality notation, then it'll become y is greater than or equal to 5, or y is less than or equal to 5. If we want to use the interval notation, that'll be my open parenthesis minus infinity to -5 union 5 comma infinity close parenthesis. We have another absolute value related inequality. Absolute value of w minus 15 is less than or equal to -9. We want to get absolute value of w by itself on the left side. So we want to remove -15 on the left side. So we add 15 on both sides. Then these two will cancel each other. And left side will have absolute value of w less than or equal to 6. This time, that means the distance between 0 and the points are less than or equal to 6. on the number line, this is 0, and this is 6, and this is negative 6. And then distance between 0 and 6 is negative, less than or equal to 6, means we have to include all the points between negative 6 and 6. 6 must be included because of this equality sign below inequality sign. Another notation will be from negative 6 to 6, and we use inequality notation. The interval notation will use the bracket, open bracket, minus 6, comma 6, close bracket. In the next problem, we have to write an absolute value inequality for the graph below. As you can see, here is the 0, and arrow start from 0, and that's greater than 6. So when we think about the distance must be strictly greater than 6. So x must be greater than 6. And for this part, again, the distance from 0 is greater than 6. And the inequality notation is x is less than negative 6. I didn't include equality sign because we have circle notation. That means it doesn't include the boundary point that is 6 and negative 6. This is inequality notation, but we have to use the absolute value inequality. So when we convert that into the absolute value inequality, with absolute value, everything is positive. So absolute value is strictly greater than 6. In the next example, we have to graph the inequality in the coordinate plane. Y is less than negative 1, but this is an inequality on the coordinate plane. That means no matter what value x value can be, as long as y value is less than negative 1, then that'll be the solution for this inequality. When we think about y equals negative 1, that's a horizontal line. And this is that horizontal line. This is y equals negative 1. When we look at the inequality sign, it doesn't include equality sign. Therefore, we have to mark with the dotted line. I said as long as y value is less than negative 1, no matter what x values are, that will be the part of the solution. So it will contain all the lower part of the horizontal line. In the next inequality, we have y is greater than or equal to minus 4x minus 5. The first thing we have to do is we have to graph y equals minus 4x minus 5. and then the slope of the line is -4, which can be written as -4 over 1. This is a slope-intercept form. So when x equals 0, y value is -5. That is the y-intercept. And then we have to figure out another point on the straight line. When y changes, x changes by 1. So when we add to the x coordinate of the y-intercept, y will drop by -4 because change in y is -4. So -5 was y-intercept, and then we subtract 4 here. Then we have 1 and -9, and we mark at that point and join with a solid line. Why did I join with a solid line? That's because there is equality sign. So all the boundary point on the straight line is included in the solution set. When we determine the solution set, it'll be either right side of the straight line or left side of the straight line. So it is enough to choose only one point to check the correctness. So I chose 0 and 0 here. If it satisfies the inequality, then the plane that contains 0 and 0 will be the solution set. The choose one. So what we do is we choose 0 and 0. Y value is 0, so I wrote y equals 0 and -4 times 0. So x value is 0. I plug in 0 here. So by plugging in those coordinates in the inequality, we know that the left side is 0 and right side is -5. So what we know is this is the true statement because 0 is greater than or equal to -5. So as I said, the entire side in the plane that contains a 0 will be the solution set. So that must be the right side of the straight line. In the next problem, we have to graph inequality. We have inequality -2x plus 3y is less than 12. This time, there is no inequality sign. There is no equality sign, so we have to use a dotted line. Let's get y by itself on the left side. To do that, we have to add 2x on both sides. Then left side will be 3y. Right side is 2x plus 12. We divide by 3 on each side. Then left side is y. That's less than 2/3 x plus 4. This is 3 times 4, so those two cancel each other. When we think about the straight line, that's y equals 2/3 x plus 4. This is y-intercept. And 2/3 is slope. Y-intercept is 4, so I mark it 4 here. And the coordinate of y-intercept is 0 and 4. And slope is 2/3. So I add 3 to the x-coordinate and 2 to the y-coordinate. Then we have 3 and 6. So I mark at 3 and 6 right here and join with a dotted line. As I said, the solution will be either the right side of the dotted line or left side of the dotted line. So it's enough to check with 1 point. Again, I will choose 0 and 0 because 0, 0 is the simplest thing to check. We have negative 2x plus 3y less than 12. So negative 2 times 0 plus 3 times 0 is less than 12. Left side is 0. 0 is less than 12. That is true. So 0, 0 is one of the solution, and entire side that contains 0, 0 will be the solution set. In the next problem, we have to graph the solution to the following system of inequalities. There are two inequalities, y less than negative 2x plus 3, and the other one is y greater than 2x plus 5. Let's graph the straight lines involved to those inequalities. Both straight lines will be denoted with dotted line because there is no equality sign. Let's draw y equals negative 2x plus 3. In this equation, y-intercept is 3. So I mark it 3 here, 0, 3 here, and slope is negative 2. That can be written as negative 2 over 1. Y-intercept can be represented by coordinate 0 and 3. So another point on the straight line will be 0 plus 1 change in x in the denominator, and y-coordinate was 3, and change in y is minus 2. So that is 1 and 1. So I mark it 1 and 1, and we join these 2 points with dotted line. In the next one, y equals 2x plus 5. 5 is y-intercept. That is 0 and 5. And slope is 2 over 1. Y change is 2. So we add 2 to 5, and x change is 1. So we add 1 to the x-coordinate of this y-intercept. Then we have 1 and 7. So that is this point, and we join that with y-intercept 0, 5. So we have two straight lines. And then what we have to do is we are solving the system of inequalities. So the solution set will satisfy both inequalities. So what we will do will be we will solve each problem, and then we will consider the overlapping part. In the first inequality, we check with 0, 0. Then y value equals 0 less than minus 2 times x value equals 0 plus 3. So it produces 0 is less than 3, which is true. So this one was y equals minus 2x plus 3, and 0, 0 is included. So it must be this part. And let's consider 0, 0 for the second one also. Then it'll produce y value 0 greater than or equal to 2 times x value equals 0 plus 5. So 0 is greater than or equal to 5, which is false. So in the solution set, 0, 0 will not be included. So in this case, it will be either this side or this side. 0, 0 is in this side, so this side will not be included. So we have to shade this part. The overlapping part will be this part. This part. So this is the solution set. In the next problem, we have to graph the solution to the following system of inequalities. The first one is y is greater than or equal to 4/3 x plus 1. The second inequality is negative 4x plus 3y is less than 18. Let's graph both straight lines. The first one will be denoted with solid line because all the straight line will be the part of the solution. But in the second case, there is no inequality, so the straight line will be denoted with a dotted line. Let's solve the inequality. We want to get 3y by itself on the left side, so we add 4x on both sides. Then left side is 3y and right side is 4x plus 18. And then we divide by 3 on both sides. And so y is less than 4/3 x plus 6. So the graph is involved to y equals 4/3 x plus 6. This is a slope-intercept form. So y-intercept is 0 and 6. And slope is 4/3. So it passes 0 plus 3 and 6 plus 4. So that is 3 and 10. So we denote 0, 6, and 3 and 10. So we mark it here and here. And then we have to join that with a dotted line because we worked with the second inequality. So I did it. Let's draw the straight line involved to the first inequality. Y is greater than or equal to 4/3 x plus 1. Let's draw y equals 4/3 x plus 1. Y-intercept is 1, 0, 1, and slope is 4/3. It passes 0 plus 3 and 1 plus 4. So that is 3 and 5. So we have to join 0, 1, and 3 and 5. So we mark it 0, 1, and 3 and 5 here. And we have to join with a solid line. Now it's time to check inequality. I would choose 0 and 0 with the second inequality. Then -4 times 0 plus 3 times y value 0 less than 18. When we calculate the left side, it is 0, right side is 18. Definitely, this is a true statement. So the solution for the second inequality, this inequality must contain 0 and 0. So that is related to this dotted line, and 0, 0 is here, so that contains this side. In the first equation, which is y is greater than or equal to 4/3 x plus 1, then when we check with 0, 0, y equals 0 greater than or equal to 4/3 times x equals 0 plus 1. So 0 is greater than or equal to 1. So what can we do with this? So this is false, right? So with the red straight line, it should not contain this 0 and 0. So we have to shade the other side on the plane. So overlapping part is this middle part. So this green colored region is the final answer.